All right, let's talk about composition now. All right, here's a library that I actually put out um, earlier this year, and it's called Blazor MVC. Um, there's actually some user group talks and a previous Clear Measure webinar where I've gone through Blazor MVC, another bigger topic than we have time for. It would take its own hour just to go through it. But go to NuGet.org, look for Blazor MVC. The URL to the Git repository is there. You all the code, either use it as a library or grab some of the interesting bits. It has an eventing bus implementation in it, and it has a handler bus that implementation in it. But effectively, this makes it really easy to create a model view controller pattern in our application. Let me tell you what I mean. And if you're not familiar with a model view controller pattern, just search the web. You'll probably find some original papers from 1975. It's a really old pattern. And then, of course, ASP.NET MVC applies it to stateless web applications. But let's take the counter controller and let's separate the controlling logic from the view logic. And so here we have a counter controller. We say, you know what, the controller needs to happen first. The controller needs to get on the call stack first and decide whether or not it wants to use the counter view or something else. So the counter controller happens first. So we give the routing responsibility to it. Notice the route attribute above it. Now the @ symbol page in a Blazor component, that just compiles down to a route attribute anyway when it compiles into assembly. So it's the same. It's literally the same code. So the controller happens first, sets some information on the counter view, and then responds to the on-click as an action, as a callback. And so that's the separation. All right. So go check out Blazor MVC. That's all I'll talk about it now. But that enables you to separate what something looks like from what something does in a Blazor application. And for simple Blazor applications, okay, you don't need any separation. You're going to be fine anyway. But real sophisticated growing applications, you need to implement patterns like this. Okay, now let's talk about responsibilities like abstractions and startup. All right, let's just take the example of Blazor WebAssembly. You're going to get right out of the box, you're going to get a project for the client, you're going to get a project for the server, and you're going to add other projects that talk to a database and whatnot. We all know this is time tested. We don't want to couple our user interface with data access or directly to any other dependencies. So we separate our code, we separate our data access code to its own library and have it implement abstractions that are defined by a core project. And the core is kind of the center of our application. It has all of our entities, it has our data access interfaces, and our user interface code does not have a reference to data access. It has a reference to core, to the abstractions. And then we use the services collection inversion of control to get implementations of those interfaces, which, by the way, happen to be classes in the data access project, which implement those abstractions interfaces that are in the core project. Okay, so that has been long established. And if that's a new concept for you, just search onion architecture. There's plenty of material about onion architecture. And even in the Java industry before that, hexagonal architecture. And there's plenty of examples there. Actually, I have a multi-part onion architecture walkthrough on Programming with Palermo that's halfway published so far. So you can check out some of those videos. But this is what I want to talk about. One responsibility in a Blazor application that's not factored away from your logic is the responsibility of starting the application, starting and configuring the application. Now, the default template puts all of the configuration and startup logic in the program CS file in your server application, all right? Where we create the host builder, we set up the services collection, we add Blazor, all these things, and then we call build and we call run. Okay, so That is configuring the application. We read in app settings.json and all that. So we configure and then we run the application, start up the application. That's a responsibility. That's an important responsibility. And the code that does that cannot be the same assembly that defines abstractions because they're different. If you are the code that defines abstractions, then all the other projects in your Visual Studio solution reference you and you reference none of them. You're not even aware that they exist because they implement your abstractions. You don't care if they do or not. But the code that configures and starts up the application is totally opposite. It can't implement any abstractions because it has a reference to all your other projects. Your other projects don't have a reference to it and don't even know it exists. In order to configure the whole application, you have to know about the application. So that is your promiscuous project. You know about all the other applications because you have the responsibility of configuring and starting up. Now, by default, the template puts your web API controllers for your web services, and I advocate only having one, in the startup project, which configures and starts up, and by its nature has to be promiscuous and have references to every other project in your Visual Studio solution. So this pattern here that I want to highlight is factoring out your web services into a different project. And on the right-hand side of the screen, I called my application UI. So I got UI.client, UI.server. And so I've created another one called UI.api. I have UI.api referencing core. And then I have UI.server stripped out of anything else except configuring and startup of the application. So if you see on our dependency diagram on the left side of the screen, UI.server is hollowed out to just the configuration and the startup responsibilities. It has references to the other projects in the Visual Studio solution. UI.api has our web services, which is going to end up having server-side logic. And then we have our web services with no intimate knowledge of our WebAssembly, and neither of them have knowledge of data access. It's all properly structured. We're making use of the abstractions in our core project, and yet we have a very thin but effective startup project, which is, in this case, is UI.server. And then all the debugging in Visual Studio works appropriately and everything gets started up because the WebAssembly debugging is hooked up and everything like that. And then your integration tests that have to know about everything, they can just reference your server project and you get all the rest by flow through.